Assalamualaikum everyone. We are from Group 1, S41. Today we'll be presenting about population growth in Tanzania. So before we start presenting, this is our team members. My name is Alia Shafini. To start with, we will be discussing population growth, which is an important topic because it helps us understand how a country develops over time. So task 1 is carry out to fulfill the assignment's objective. In this presentation, we focus on population growth of Tanzania between the years 2000 and 2020. To analyze this, we use first-order differential equation. Specifically, we apply the Malthusian model that was developed by Thomas Malthus, an English clergyman, scholar and economist, to determine and study the pattern of population growth in Tanzania during this period. Alright, next I'm going to explain about data of population growth. So, from the table on the left, we can see Tanzania's population from the year 2000 to 2020. In 2000, the population was about 34 million, and by 2020, it had grown to over 16 million. This shows a steady and significant increase over the 20-year period. So, this data was obtained from the World Bank. The population has been rising consistently each year. So to understand this growth mathematically, we use the Malthusian model. This model stated that the rate of population growth is proportional to the current population size. So the formula can be written as derivative of P with respect to T is proportional to P, or derivative of P with respect to T equal Kp, where Pt represents the population at time T and K is a constant. So in simple terms, this means that as the population increases, the rate at which it grows also increases.
Next is calculation process to analyze the human population growth mathematically by using application of first-order differential equation. First, we let Pt to the number of individuals at time t. Since the rate of individual is proportional to the number of individual Pt, it will be dp over dt is equal to kp, where k is constant of proportionality. Solve it by using the method of separable variable by first separating the variable p and t. Then we integrate both sides of the equation to find the general solution, and it will be p equal to plus minus ae of kt. The general solution can be simplified to be p is equal to ae of kt, where a is equal to ec, and by using the initial condition t is equal to 0, we can find the value of a, which is 43,633,982. We also calculate and found the value of the constant k by using t is equal to 1. Then we find k is equal to 0.025445. Lastly, the particular solution becomes pt is equal to 43,633,982 e power of 0.25445 t.
So first of all, we take the t equal to 1 as the reference point, and then to predict the future value, we choose 2011 as t equal to 2. So when inserted into the solution earlier, it will be p equal to 43,633,982 e to the power of 0.025445 in bracket 2. And the answer will be p equal to 45,911,974. For the second one, we'll take t equal to 0 as reference point, and to predict the past value, we choose 2011 as t equal to -1. So it will be p equal to 43,633,982 e to the power of 0.025445 in bracket -1. And the answer will be p equal to 42,043,537,728.
Moving on to the graph, Figure 1 shows the graph of actual population in Tanzania. Each dot represents the population at a specific year. The curve is slightly upward bending, suggesting that the growth is speeding up over time. Meanwhile, Figure 2 shows the graph of particular solution for population growth in Tanzania. This graph increases exponentially, meaning that the model predicts that the population will grow faster over time. Here, Figure 3 is showing the graph comparison from the dataset and the graph of the particular solution. Both graphs that is plotted increases in a fixed pattern, indicating that the values are consistent.
My name is Ainul and I will be presenting this slide that shows the comparison between the actual value and predicted value. We calculate the percentage error by using the formula actual value minus predicted value divided by actual value times 100%. As for the result, for 2008, t equals to 1, the error is 0.078, which is very small. For 2009, t equals to 0, the values are the same, so the error is 0%. For 2010, t equals to 1, the error is extremely low at 0.00016%. For 2011, t equals to 2, the error increases slightly to 0.26%. So overall, the average percentage error is about 0.312%, which indicates that the model is accurate and reliable.
So the table here represents the differences between actual values and particular solutions value. So as we can see, there's quite a discrepancy between them. So one of the reasons of why is because of the model simplification. The mathematical model simplifies complex real data, leading to small deviations like 0.078% or 0.26%. So the second reason is the external factors that are not included in our slides. For example, economic changes, environmental factors, and human behavior. These factors can make actual values slightly shift from predictions. The third reason is the rounding and approximation. Tiny rounding of numbers during calculations leads to a slight percentage error. And lastly, and the fourth reason, is the measurement or data collection errors. The instrument limitations and recording errors can create a gap between actual and predicted values.
So the three factors that were influencing the population growth in Tanzania would be the high fertility rate, the declining mortality rate, and the urbanization. So the high fertility rate, women were averaging about 4.8 children per woman, and because of that there was an increase in population, and also due to the fact that women were offered limited educational opportunities, so they were forced into the mother role. So second, for the declining mortality rate, there has been significant improvements in healthcare and medical services as well as nutrition in Tanzania. So it improves the life expectancy and improves the living conditions of the people. And third, the urbanization meaning that there has been a lot more migrations from people in rural areas to the towns and cities. So a few factors that will be influencing the population growth in Tanzania in the future would be the gradually declining but persistent high fertility rate, the decreased mortality rate, and the cultural and policy shifts. So because of there is an increased access to education and empowerment of women, there is going to be a lot of maternal and child healthcare improvements, which lowers the child mortality rate. There's a lot of advancements in medical fields, and there's a lot of families have better access to contraceptive methods and family planning. And for the cultural and policy shifts, there's going to be a lot of urbanization and economic shifts, which can lead to a lot of higher cost of living, bringing about a smaller family size. So in conclusion, the calculation process used in this video is a simple demonstration on how predictions of population growth is obtained via mathematical methods. So it is essential for governments and organizations to use the data, the prediction data for planning and resource allocation and policy making to organize the country. It also converts historical data, which is the input data, into future estimations to help governments and organizations to prepare for these shifts in population size, structure, and distribution.